Okay, I'm here with another Tech Talk with Paul and Al, and Paul is working on an old turntable.
Oh, a little toy record player.
A toy record player,
This was probably the first record player that Voice of Music of Benton Harbor, Michigan made as a record player. They were known for making record changers. This appears to be their foray into making a modestly priced 3-speed turntable. Their specialty was making cast zinc machine parts. And I think this tone arm was probably something that they created and molded. It's plastic, but it's got quite a unique style to it. I got it off of eBay really cheap. It's a little shabby, has that wonderful smell, and let me see if I can drop it back together. It's a little 2-tube amplifier. One tube is missing and got broken in transit. Simple little amp, little wooden box. This was probably made about 49 or 50. And it went for 99 cents, and I felt sorry for it. And I liked this tone arm. It's a very stylish tone arm. It has the old crystal cartridge in it. Probably was fitted with a 2mm universal stylus. A 2mm needle would play a 78 or an LP 45 equally well, which means not very. A 78 took a 3mm needle, and an LP took a 1mm needle, but a 2mm needle falling in between the two would play both of them, sort of. I thought, well, for 99 cents, it's Voice of Music, which is an iconic company. It's got the big flat platter. It is 3-speed, and it needed a home. So I'm re-gluing a little piece of wood that holds it together, and we'll probably find a tube for it. I mean, it's a 50C5, it's a common tube. The cartridge obviously is bad. And I've been meaning to look in here and see if the idler wheel is any good. Oh, it's a turret drive. Those are neat. Also a nightmare.
Explain it as a turret drive.
Well, in the early days of multi-speed turntables, it was hard to get one motor and one drive wheel to accomplish those 3 speeds. So they took the existing 78 RPM motor and used these 2-step intermediate idlers called turrets. This one has a larger bottom and a smaller top, and this is a smaller bottom and a larger top to get the different speeds. So you've got this driving this to achieve the 3 different speeds. Kind of cumbersome, but it worked. Later years, they took a motor with a different diameter shaft and usually just cut different diameters in the shaft of the motor to get the 3 speeds. But this worked without moving the idler wheel up and down, which is what they did later. You still used your skinny platter, which had been used for the single-speed 78 players for years. It was kind of a compromise. But these turrets tend to get slippery, and they are hard to find because nobody made them after the 60s. You find a new old stock occasionally, and they'll work. In a single-play turntable, the turrets don't have to be good because they don't have to develop a lot of torque to turn a record. But if you've got a turret drive and a record changer, they've got to be good sticky rubber to drive that record changer, and they frequently won't. But this is neat. This would have been a pretty well made unit in its day. So I rescued it for 99 cents.
Now these were used in schools and such?
Oh no, this was your basic children's record player. Or your really poor, sad, pathetic adults record player. Now these were not for school. Schools may have bought them. Now RCA had a school record player division, and they made record players marketed to the schools, and they were basically identical to the ones they sold to people at home, but they marketed them to schools. This was just an AV product, and it's model number 110, which means it's probably the first thing they made. They had been making record changers since the end of World War II. This would have been 1950, probably, having all 3 speeds, 49 or 50. I liked the tone arm. I've seen this tone arm several times. I thought, well, that's neat. I've never seen it on anything else. So I bit the bullet and bid on it, and nobody else bid, so I got it. But the smell is wonderful. That old moldy school glue kind of smell. Very nostalgic to people my age.
Have you tried powering it up to see if it turns?
I haven't plugged it in yet. I mean, we got nothing to lose. The tube's missing. And it probably will. Oh. There we go. I don't know what that noise is all about.
Is it coming out of the speaker? Or?
No, that's mechanical.
Bad motor?
Well, it sounds like one of the bushings is probably loose, or who knows. Let me see here. Something. It's a motor issue. So like it's rubbing on the bottom bushing. I mean, that's just something we'll have to deal with. I just thought it was cute, it was cheap, and I felt sorry for it. So
and you can actually play records on it when you fix it.
Oh yeah.
And it won't sound bad. I mean,
one tube doesn't give you much fidelity, but you know, the music when this machine was made, there wasn't a lot of fidelity. You were interested mostly in the voice, because people could sing back then. And a good singer, one reason singers proliferated in the days of radio and then in the early records is because the human voice is easy to reproduce. It's on a narrow bandwidth, easily achieved by phonograph records and AM radio. So if you had a good singing voice, you came through loud and clear. This would sound great with Rosemary Clooney or Bing Crosby or you know, anybody from that day with a good voice. Today's music, if it's not played on a CD player or an MP3 that can handle all that noise and those frequencies and those conflicting notes and distortion, would never fly on a phonograph record. It just sounded like crap. I think it sounds like crap on an MP3 player, personally. But music used to fit the recording and reproducing device that was available at the time it was made. Music was made to fit the radio. Music was made to sound good on 78s. And as the recording industry changed, so did the music.
That's a very interesting insight there.
Just my theory. Back then, we listened to people who could sing.
Of course, you know, one thing that reminds me of is the recording industry, like the Recording Industry of America, went to all kinds of trouble when they finally came out with high-fidelity radio to reduce the fidelity of high-fidelity radio.
Oh, RCA did a study back in the 40s to prove that the public really didn't want high fidelity. They found it annoying. They were happier when they were demonstrated radios that had lower fidelity because they didn't hear scratch and hiss and objectionable overtones. That they liked low fidelity. This was to RCA's advantage. Other companies ignored RCA and gave us high fidelity, and gradually we came to realize that we like high fidelity. But RCA wasn't interested because they didn't want to have to make it.
Yeah, what I'm thinking about is when FM stereo came out, the Recording Industry of America made the broadcast industry reduce the specs of the FM, way down to, what was it, 15,000 cycles, and that was the max. What was it? Was it 18 or what was it? I mean, they didn't go to the full high end. They didn't go to the full low end on broadcast FM.
FM can do 15,000, which is more than adequate. And one of the reasons is on FM stereo that you carry the pilot frequency for demodulation at 19 kilocycles. So you had to have enough space between your peak audio frequency and your carrier that there was no chance the two would ever meet.
Yeah.
So you're transmitting a 19K pilot tone.
And you're at 15 below.
Yeah, 15 dB below in your program material. It's actually buried in the music. And that has to be picked out, doubled to 38K, which is then used to demodulate stereo.
Right.
So, yeah, you could probably transmit FM up to 16 or 18K, but then you couldn't have your pilot.
Yeah.
Mono FM conceivably could have gone 16 or 18, but stereo had to be below 15.
Yeah, but I think it was a lawsuit by the RIAA that made, when they wrote the specs on FM radio, made them so that it never could be as good as a phonograph or a turn.
That's probably possible too, but with FM stereo you couldn't go any higher anyway.
Yeah.
And the average person can't hear the difference. Some people say they can.
Yeah.
But if you're over 21, if you listen to rock concerts or those things in your ears,
you lose that high end real quick.
You're already half deaf.
Yeah. I know, you lose it. You know, babies and women and younger kids, they hear real good, but they don't appreciate it.
Back in the old days when televisions had horizontal frequency sweep circuits,
you could hear them.
Younger people could hear that 15750 kilocycle sweep frequency,
and you knew it was doing that
as a little high frequency whistle. We could tell that the TV set was working. As you get older, it gets harder and harder to tell.
Yeah, one thing.
Of course, now flat screens don't have that. And modern TV sets make very little noise.
Well, I remember when I was, I used to work on TVs at a TV shop when I was even in high school.
Yeah, I did too.
And I could listen to that TV and I could hear the 15734.834 horizontal.
Yeah, hear that oscillator come up.
And then you put the back of your hand up against the front of the screen, you could feel the static charge.
Yeah.
And you knew you had high voltage.
That's right.
And so, you could tell a lot.
That's more ancient history.
Yeah.
But
I remember they were talking about the first specifications for FM had the pilot up around 25.
Well,
and then the RIAA came in and said, no, we're not going to broadcast as good as they can buy.
Well, you can bet that when Armstrong or whoever, Armstrong didn't do FM stereo, whoever wrote the specs went for the moon. And the pilot could have been any place. And they could have gone as high as they wanted to with frequency. FM modulation, the sky's the limit. But yeah, I can see where RIAA would put a limit on it. And to do stereo efficiently, 15K with a 19K pilot is probably very doable.
Yeah, and of course when they
the pilot too high could be a problem because you have to make a receiver that could pass that frequency.
Yeah.
And the average American manufacturer would not have wanted to do that.
Yeah, it's a lot more parts.
It's like everything else: compromise, compromise, compromise.
Well, I remember when they came out with the old television stereo, the analog television stereo.
Oh God, what a nightmare!
And that was much lower frequency. And actually, the pilot on that was around 15. I think it was the horizontal frequency.
It was sandwiched in.
Yeah, and so it was stereo, but it still had a lower high end.
Amazes me it ever worked.
Well, the thing that really I thought was weird was AM stereo. They came out with that.
Broadcast AM? Yeah, God.
That never really did work.
It worked, but it's like, it came in at the time when AM was losing music and going to all talk, and it did sound better, and some of the car companies put AM car stereos in their cars for a while, hoping to sell some more cars and car radios. It was too little too late. I listened to it a time or two and thought, well, this is nice, but most of the stations playing music on AM weren't playing a stereo music to start with. And of course, you go to their commercials and they were like, yeah.
Well, I thought one of the other weird little notes about FM stereo, the early days of broadcast stereo on FM, there was a time when they actually had one channel on the FM transmitter and another channel on the AM transmitter.
Yeah, pre-64, they experimented with that. The simulcast system. You'll find Heathkit and a number of other kits tuners and a few factory-built tuners, and there was Stromberg Carlson did it, RCA may have done it once, some companies did it, some companies didn't. You had a tuner that had a dial for the AM tuning and a dial for the FM tuning,
Mm-hmm.
so that the tuning gangs were not tied together.
Mm-hmm.
So you could tune two separate stations,
Mm-hmm.
and then the selector switch lets you use one, the other, or both for stereo.
Mm-hmm.
And there were experiments done with stereo transmitted that way. One channel sounded great, one channel sounded like crap.
They had
But
pops and hissing noise.
they were selling the effect.
Mm-hmm.
One year they did the Lawrence Welk show in stereo,
Mm-hmm.
and they simulcast with local AM stations.
Mm-hmm.
To put one channel on your AM radio and one channel on your television. My father did that, and it was just like, wow, this is amazing. It's like, yeah, didn't do very well.
But they'd come up before the show and advertise and tell you how to do it.
This was 2 weeks in advance.
Yeah.
Get your radio and put it next to your TV and tune it to this station, and at this time we're going to do this amazing demonstration of stereophonic sound on television with the Lawrence Welk Orchestra.
I remember one of the weirder things about that era was you get in a magazine and you could order a plastic sheet to go over the front of your TV picture tube, and it was like blue at the top and red in the middle and green at the bottom.
That was so silly.
And it made your black and white color.
Colored.
Well, it wasn't really a color TV because it wasn't real color. It was just
it was colored. It was colored, like coloring a book.
Yeah.
It was colored television, not color television.
Yeah, but we also had a lot of those weird things like the television, like the CBS system that actually had spinning color filters.
Yeah, that was
and drums.
color, and that was not a bad system. It was just very cumbersome. And it was not compatible with the existing black and white TV sets, which would not have been very nice for the American public. We could do a whole month on that subject.
Well, eventually it would have become non-mechanical, like CCAM.
CCAM in Europe is non-mechanical sequential color, yes. And the picture's great. Once your eyes get used to the flicker, it's not bad. The CBS Columbia system was supposed to be so good. A heart hospital bought the system, they were the only ones that ever did, and used it to transmit heart surgeries across the country to medical students. And they say that the first students to watch a heart operation on the CBS Columbia color system, the colors were so good that students fainted from the sight of blood. That's high praise for a television.
Yeah.
Because the colors, you've got all four colors in full bandwidth. Which would give you an equivalent resolution in the 1,000 lines. And in 1952, that would have been huge. Small screen, but the colors were supposed to be exquisite.
Well, they actually had some of the bigger screens with a big drum running around them. They had a colored drum and the tube was in the middle.
Well, they tried a cylinder system, but they only produced the spinning disc. They thought maybe the drum system might be easier to put in a cabinet because the spinning disc was cumbersome.
Yeah.
12-inch picture, and you've got this Ferris wheel disc sticking out of the front.
Yeah. Well, one time they were talking about one of the first ones was in an apartment in New York, and the disc flew apart and tore up the apartment, hurt people.
Could have been a problem.
Yeah.
RCA wouldn't hear of it, of course, because they wanted to control the world. And making a large picture with spinning disc was very, very difficult.
Unless you use projection.
Well, RCA had projection color day one. Back in the 40s when they were developing color television, black and white television. They had color down with RGB and 3 color projection units focused onto one screen using mirrors. Although we had color back in the 40s, experimental. And they considered making projection sets for home use, but they would have been huge and expensive.
And not that bright, actually.
The brightest wouldn't have been bad, but the X-rays and the weight, very expensive. They figured out real quick that was not going to work for the general public. They experimented with it for theater use, which was easy. But the fact that RCA or anybody was able to sit down in the early 50s and come up with a 3-gun, 3-dot, 3-phosphor a tricolor picture tube and get the precision of drilling and placing the dots in that aperture grill and depositing those phosphor dots on the face of the tube and getting the alignment close enough that you could sweep that tube's face and get the colors to land on the right dot 90% of the time in 1954 is like putting a man on the moon. We didn't have lasers or any of the thing we have today to do precision drilling and placement. This was all done the hard way. That aperture grill was drilled with acid. And the dots were sprayed onto the face of the tube. And the reason we use red as the color we use for purity is because red is the first dot put down, therefore it is the smallest. The other colors are put down over it and are larger and overlap slightly. So red being the smallest dot was the most critical. So if you got it hitting the red dots where you can make a solid red screen, blue and green were a piece of cake.
Well, I remember they also had something called a Lawrence tube.
Philco had the Apple tube, which is almost the same as it wasn't the Trinitron.
But it was close.
It was Sony built the Chromatron experimentally, which is a 3-stripe color tube, red, green, and blue stripes vertically, no aperture grill, but there's a field of tiny little metal wires
that would deflect it at the face.
One electron gun, and as the beam scanned across, those wires were charged to push the beam left or right to hit the correct stripe at that instant. And it had an anode cable for the tube, and it had 3 anode caps that had modulated pulses on it to energize those wires to push the beam left or right to make color. And it worked.
Well, that was sort of like the Lawrence tube too.
Yeah.
And I heard this thing that the Lawrence tube was offered to the RCA, and the thing about it is it allowed you to build a color TV with significantly less components.
But RCA owned the patent to the Delta tube and did not want to give it up.
So they sold it to Sony.
Yes.
For a very low price.
Yes, thinking Sony would never do anything with it. They built some Chromatrons, and they worked. They were finicky, but they worked. But Sony figured out they could go with 3 electron beams with 1 focusing lens. Use the stripe pattern phosphor, but use an aperture grill to separate the crossover point. And they had the precision to make that grill and position it. And you got a tube where 90% of the electrons hit the phosphor. In a Delta tube, only about 60% of the beam current hits the screen.
Right.
Most of it's wasted. So you got a bright picture, easily converged, if you knew the secret. No aperture grill, no pattern. It was just a pure color picture.
And that's what gave Sony the advantage.
For many years. The Trinitron is the best tube ever invented. Now, Sony did go back and make a 1 electron gun aperture grill-less color picture tube, the Indextron. And that was a 8-inch picture tube, 1 electron gun, the usual color stripes, but the difference was on the back side of the stripes, inside the picture tube, there was a green stripe between every triad of red, green, blue. And that shone a light back into the bell of the tube, which was picked up by photosensors. And they did a phase lock loop to track the beam across the tube, and they knew where the beam was at any given time, and they turned the beam on and off so that it only hit the right stripe or the right pair of stripes to make color. The only thing was the tube couldn't be made very big, and you could not screw with the horizontal width. It had to be precise. Otherwise, the frequency output by the green stripes would be wrong, and you couldn't do keystoning because that screwed it up. So you had to have precisely sized image, no keystoning. Vertical you could screw with, it didn't matter. But it made a picture on an 8-inch tube bright enough to be projected as a projection tube. We had some direct view indextron monitors that we dubbed the sunglass monitors because you couldn't look at them indoors without sunglasses. They give you a headache. The film people loved them because they were bright enough to be seen in sunlight. While you're out on a film shoot and you need a field confirmation monitor, you could see these in daylight. But they never sold enough of them to put them into production. There's a projector called the, what's that thing called? And I just went blank. I've got some of them. It's a 1-2 projector. Boy, it's got a good name too. We sold a bunch of them, and they worked, but you had to turn out all the lights in the room to see them. But it made a picture with 1 tube.
Well, speaking of weird projectors, system, what about the Idafor, or Edifor, or whatever you call it?
Which became the GE light valve. Yeah. That's a whole nother subject.
An oil bath.
That predates the picture tube. That's an electron beam scanning a glass plate dipped in oil. And the oil becomes reflective or non-reflective based on an electron beam scanning it and cutting little grooves in the oil. And they later found out they could modulate the beam with a high frequency and get diffraction grating and create color the same way. So you could get this one channel device to not only make a bright television picture at any scan rate, because it's electrostatic drive, your scan rate is limitless, but you modulate the vertical to get a little squiggle, and you could create colors in the oil by the diffraction grading process. I'm probably pronouncing that wrong. Idafor made it in the 20s, and then the 30s and 40s. And then GE bought the patent and did the light valve, which became the Talaria, which is a sealed unit with a glass plate and pumps and oil and heaters. But boy, when it works, it works.
Well, that was actually in 1969 when the first man walked on the moon. NASA had those big screens.
Yes. Anytime you watch the Grammy Awards or the moonwalk and you had live people in an auditorium and you saw a projected live television image to the left or right of the presenter that was bigger than life, that was a Talaria. It was the only projection system capable of doing a theater-sized projection. These things were fed with the same arc lamp as a film projector. They didn't pass through the plate of oil, they bounced it off the oil and then back up.
It's sort of like the modern DLP. Similar.
DLPs are a switchable mirror. It's a very similar concept, yes. But Talaria, GE, many years ago, we're talking the 90s, one day walked in and says, "We quit. We're no longer supporting Talaria. It's been fun. Goodbye, folks." There were people who made their careers, their family businesses around owning and leasing Talarias. And one day GE just walked away. They said, "We're through. We quit." Sad.
And they really had nothing to go to at that particular time.
They were starting to get LCD projectors were becoming more common and getting brighter. But there was a short time there when you really couldn't get anything to compete with the Talaria. But GE bailed, and of course that just made more room in the industry, and Japan ramped up and got bigger and bigger and bigger. Christie, NEC, all came up with megawatt LCD projectors and then DLPs, which are far superior in terms of brightness and contrast to an LCD. And hence, all the movie theaters are digital thanks to TI, and film's out the door, and I hate it.
Well, yeah, that's quite a change. I mean, I don't know. There's maybe 1 or 2 film processing places left.
Maybe 2.
And then you go to like get a professional film camera like an Arri or a
well, according to a guy
Panavision.
There's a place in Jersey and a place in California there are still professional film people shooting 16 and 35.
Yeah.
But there's only 2 plants left.
Yeah, and then but now you just go get a like an Arri Alexia, which is full digital, and instead of buying a mag of film, you get a mag of memory.
Yeah.
Stick it on the back.
Well, we used to shoot digital, and then transfer it to film, and then project it. And we don't have to do that anymore. We just process it, do all the digital magic, and right into a hard drive into the theater.
Or sometimes they send it over the internet, slow speed.
Yeah. We've cut out film completely.
Yeah.
Which is sad.
Well, I mean, they don't. I don't think you can get Kodachrome processed anymore.
There's one place I talked about the other day that you can still get film processed. It's horrendously expensive. But yeah, the world keeps changing. And I keep sitting here talking about it.
Well, this was a fascinating tech talk. I'm going to have to call it number 1 of our repair of this turntable, but also a whole lot of talk about television. And
yeah, this was just a good toy. Nice place to start a conversation. You know, you can ask me how the weather is. The next thing you know, we're talking about technology.
Yeah. Well, old technology is particularly fascinating.
Yeah.
So this is our end of
old folks, old technology.
Yeah.
We love our past.
But that helps us understand the new technology too.
Yeah.
If you don't, if you learn how to work with the old stuff, the new stuff's pretty easy to understand.
It's nice to know where you came from.
Yeah. Well, that's it, Paul. We're going to call it the end of this particular tech talk.
Okay. It's been fun.